In today's video, I'm going to talk about some review questions for test 1 on DC fundamentals. So the first one is perform the power calculation. So the first question will be 7.29 times 10 to the minus 4 plus 0.36 times 10 to the minus 3. So that would be 7.29 times 10 to the minus 4. In order to do the addition, we need to have the same component for the power. So that would be 0.36 times 10 to the minus 4. Before we have 10 to the minus 3, so if we want to change it to 2 to the minus 4, that would be times 10. So we multiply by 10. So that would be 7.29 times 10 to the minus 4 plus, then we use 0.36 times 10. That will give us 3.6 times 10 to the minus 4, which is 10.89 times 10 to the minus 4. If we want engineer notation, we can change that to 1.089 times 10 to the minus 3. That's the engineer notation. So the second one, let's just be, so 16900 minus 44000. That's another 0 here. So basically that's a 169 times 10 to the 3. So the decimal is here. We move it to the left 3 times. We change that to 10 to the 3 minus 44. Same thing for this guy. It's a 44 times 10 to the minus 10 to the 3. Then we have just use the coefficient subtraction. So 169 minus 44 times 10 to the 3. That will give us 125 times 10 to the 3. Or we can write in scientific notation, that will be 1.25 times 10 to the 5. That's scientific notation. Then the second one is perform the calculation for the multiplication. So the first one is 4.45 times 10 to the minus 4 times, or divided by 7.56 times 10 to the 7. So when we do the power division, we use this guy divided by this guy, 4.45 divided by 7.56 times 10 to the minus 4 divided by 10 to the 7. So that will give us 0.589 times 10 to the minus 11. So when we do the division, 10 to the a divided by 10 to the b, it will be 10 to the a minus b. So here we have 10 to the minus 4 divided by 10 to the 7. That will be 10 to the minus 4 minus 7. So 10 to the minus 11. Or we can change that to 5.89 times 10 to the minus 12. Every time we move the decimal from the left to right, we need the times 10 to the, let's say 5.89. It will be, if we move the decimal to the right one place, that will be 5.89 times 10 to the minus 1. If we move it again, 58.9 times 10 to the minus 2. Every time we move the decimal to the right, we need times 10 to the minus 1. The third one, so we need to write the number, express the number in engineer notation. So A is let's say we have a number 4874256 and we want to write in engineer notation. So engineer notation basically is 10 to the power of multiple threes. Could have 10 to the 3, 10 to the 6, 10 to the 9, 10 to the 12, or 10 to the 0, 10 to the minus 3, 10 to the minus 6, 10 to the minus 12. So the decimals here, every time we move the decimal from right to left, we need to multiply by 10. So we move it once, we have 1, 10 to the 1, 2, 3, 4, 5, 6. So that's kind of close to 10 to the 6. What's left is 48. We move the decimal after 8. So 7, 4, 2, 5, 6, 9. So we have 6 digits after the decimal number. So we have 10 to the 6. Basically, we move the decimal from the right to left 6 times. That will give us 10 to the 6. Let's look at another decimal number, 0.02782 times 10 to the minus 3. So here we have decimal number, we need to move the decimal from left to right. Then we need times, every time we move it, we need times 10 to the minus 1. That's left to right. So here is a right to left. And when we move the decimal, it's left to right. So we need to move the decimal 1, 2, 3. If we move it 3 times, that will give us 27.82 times 10 to the minus 3, then times 10 to the minus 3. Because we move the decimal 3 times, in order to get 27.82, that's why we have 10 to the minus 3, so that will be 27.82 times 10 to the minus 6. Number 4, express the numbers using the correct metric prefix. So when we say metric prefix, means micro, mili, mega, pico, and the K. So that's 10 to the minus 6, 10 to the minus 3. Mega is 10 to the 6. Pico is 10 to the minus 12. K is 10 to the 3. Also gaga is 10 to the 12. So A is 67000 ohms. So we can move the decimal 3 times from right to left. 1, 2, 3, change it to 67, then times 10 to the 3 ohm. So we can convert 10 to the 3 to K, so that would be 67K ohm. B is 3.3 times 10 to the minus 5 amps. So that's kind of close to 10 to the minus 6. So we could get 33 times 10 to the minus 6. So here we move the decimal from left to right. So we get, every time we get 10 to the minus 1, so the total is 10 to the minus 6 amps. So 10 to the minus 6 is a micro, so 33 microamps. C 0.0075 times 10 to the 6 hertz. So that will give us, so 10 to the 6, we can change this. We can move the decimal still from left to right 3 times, 1, 2, 3. That will give us 7.5 times 10 to the minus 3 times 10 to the 6 hertz. So the total will be 7.5 times 10 to the 3 hertz. Then we can convert 10 to the 3 to K, so 7.5 kilohertz. D, we have 5.6 times 10 to the minus 11 farad. So that's the unit for capacitor. So if we move the decimal from left to right by 1 times, so that will be 56 times 10 to the minus 1 times 10 to the minus 11 farad. So we can combine these two. It will be 56 times 10 to the minus 12. Because for multiplication 10 to the A times 10 to the B, the formula is 10 to the A plus B. So that will give us pico, so 56 picofarad. Number 5 is convert unit. Let's see, first one we have 19890 seconds, 2 hours. So we all know 1 hour equals 60 minutes. So 60 minutes will be 1 minute is 60 seconds. So change that to seconds. That will be 3600 seconds. So 1 hour is 3600 seconds. In order to convert to 19890 seconds, it will be 19890. So we need to convert the unit. We want to cancel all the seconds. So we put the seconds on the bottom. So that's seconds. We put hour on the top. So that's 1 hour. So basically from here, we can get 1 equals 1 hour divided by 3600 seconds. And everything times 1 is itself. So it will be 19890 divided by, so we cancel out the unit S, we get hour. So that will be 5.2525 hours. And B is we need to convert the 60, so that will be 60 miles per hour to meter per second. So 1 mile is 1.609 kilometer equals 1,609 meters. So from here we can get a 1 equal to 1 mile divided by 16909 meter, or 1609 meter equals divided by 1 mile. So 60 miles per hour, that will be 60 times. So we need to cancel out the miles, and also 1 equal 1 hour divided by 3600 seconds also equals 3600 seconds divided by 1 hour. So for the miles, we want to cancel out the miles. So the unit of miles divided by hour. We want to cancel out the miles, so we put the miles on the bottom. So 1 mile equals 1,609 meters. And also we want to cancel out the hours, so we put the hour on the top. We will have 3600 seconds. Then after that we can cancel the unit. That will give us 60 times 1,609 meter divided by 3600 seconds. Then we can get 26.8 meter per second. Number 6 is we need to use the Coulomb law to calculate the force between charges. So Coulomb's law, it says the force between two charges equals K times Q1 Q2 divided by the distance square. So Q1 is for the charge, Q2 is also the charge, R is the distance. So let's say we have Q1 equals 1.5 microcoulomb, Q2 equals 2.0 microcoulomb, and K equals 9 times 10 to the 9. R equals 50 millimeter. In order to get the unit is Newton. In order to get a Newton, we need to use the standard unit for all of them. So we need to convert Q1 equal 1.5 microcoulomb. So it will be 1.5 times 10 to the minus 6 coulomb. Q2 equals 2 microcoulomb equals 2 times 10 to the minus 6 coulomb. So F will be K times Q1 Q2 divided by R squared, which is 9 times 10 to the 9 times 1.5 times 10 to the minus 6 times 2 times 10 to the minus 6 divided by R squared, which is 50. So 50 millimeter equals 50 times 10 to the minus 3 meter times 10 to the minus 3 square. That will give us Newton. So that will be 10.8 Newton. Also, number 7, we need to calculate the force between an electron and our charge of minus 0.33 times 10 to the minus 18 coulomb. Light are suited. Our distance of 18 times 10 to the minus 10 meter, and we also have K equal to 9 times 10 to the 9. So the charge for electron is Q1 equal 1e, so it will be 1.6 times 10 to the minus 19 coulomb. That's a constant. And the other charge Q2 equals 0.33 times 10 to the minus 18 coulomb. We have R equals 18 times 10 to the minus 10 meter. That we can get F equals K times Q1 Q2 divided by R squared. So it will be 9 times 10 to the 9 times 1.6 times 9 10 to the minus 19 times 0.33 times 10 to the minus 18 divided by R squared, which is 18 times 10 to the minus 10 square. That will give us Newton. So it will be 1.47 times 10 to the minus 10 Newton. Number 8, we have the charge Q1 equal to 0.4 coulomb, Q2 equals 0.6 coulomb. We have K equals 9 times 10 to the 9. And we have the force this time. F equals 5 times 10 to the 8 Newton. What's the distance between the two charges? So we have the original formula F equal to K times Q1 Q2 divided by R squared. In order to get R squared, we need to multiply by R squared on both sides and divided by F. So if we do that, we can move the R squared. So we multiply by R squared. That will be, we have F times R squared divided by F. We do the same thing for the right side. It will be Q1 Q2 R squared. So we times R squared divided by F. Then we cancel out the f, cancel out the r squared here. So r squared will be k q1 q2 divided by f. Then r will be square root k q1 q2 divided by f. Then we can just plug in the numbers. 9 times 10 to the 9 times 0.4 times 0.6 divided by the force is 5 times 10 to the 8. Then the units will be meter. So we can get 2.08 meter. That's kind of all the review questions for test 1. If you still have any questions, you can leave a comment below. Thank you for watching. Good luck on the test.